So today we're talking about stem and leaf plots. Stem and leaf plots are used to show distribution. They're used to organize data points quickly. They're used just to visualize lots of numbers. If you've got a large set of numbers, it's just a quick and easy way to organize things. Generally, they are used with kind of a T-chart, and you have your stem on one side and your leaves on the other. Stems are going to be the bulk of the number. The leaves are literally just the last digit of the number you're looking for. So if you had the number 37, 7 would be the leaf. 3, or in this case standing for 30, would be the stem. If you had 384, 4 would be the leaf, and 38, or in this case 380, would be the stem. If you had 237.24, 4 would be the leaf, and 237 and 2/10 would be your stem. Now, I know you're saying if you have all these different numbers, how do you know that the last number is the leaf? Well, what does it mean? Well, regardless of its place value, that last number is always going to be the leaf. And because of this, because it can vary so much in what it stands for, you need something called a key. And we're going to put that key over here in red. And what that key does is it tells you what your numbers stand for. So in this case, if you had 2, and they're going to put a long bar and a 4, that could mean that it's 24. Or it could mean, if you had another key, and you had the exact same thing, 2 long bar 4, they could tell you that it equals 2,400, in which case whatever number you've got there, you're going to add 2 zeros to. Or if you look at the green key here, again, same thing, 2 long bar 4. They could tell you that it's equal to 2.4. That key is going to be incredibly important to understanding what's going on with your stem and leaf plot. Regardless of what's going on, the first thing you need to do is look for a key. If you're making your own, you always need to make sure you include a key. Because like I said, without that, those numbers could literally mean anything. A 3 and an 8 could be a 38, could be a 0.38, could be a 3,800,000. So many different options there. You've really got to have that key and to pay attention to what it is. Otherwise, you're not going to know what's going on. So now that we have a basic setup of stems and leaves, stems being everything but the last digit and a leaf being the very last digit, let's actually take a second to look at a set of numbers we would use this with. So here's a data set. You see we've got a few numbers here. They're fairly unorganized. They're not in any kind of order. They're just kind of at random listed here. And most of the time when you get a data set, whether it be math work or whether it be in real life that you're going to have a job it's your job to interpret numbers, most of the time they are given to you in a fairly random order. There's no real organization to it. One of the things that you can use as a tool to help visualize what you have is to use the stem and leaf plot. So we're actually going to create one. And like I said, they're normally kind of a T-style chart here. Now, with a stem and leaf plot, it's important to have the numbers in order from least to greatest. Some teachers will teach you that you need to put all your numbers in order first and then make the T-chart. I feel it's easiest to make the T-chart as you go and to cross them off, always looking for that smallest number that's left. Doing it that way, you don't double your work. Sometimes people find it difficult to find that, and if you're one of those people that it's really difficult for you to find the smallest number and then the next and the next out of a large set, it may be easier for you to organize it first and then create it. So what we're going to do, we're going to look through these numbers right here, and we're going to find the smallest number on the list. And if we look, it's right here, number 10. So we're going to take that number 10, and we're going to have our stem and our leaf. So the leaf on this case is going to be a 0, and our stem is going to be a 1. And the reason it's important to make sure we have that first is so that we have the smallest stem possible listed first. In this case, the smallest stem is a 1. With that, the smallest leaf is a 0. And I'm going to go ahead and cross out that 10. I'm not going to scribble it out completely because it's always a good idea to still be able to read your numbers when you're finished in case you mess up. If you've scribbled them all out, it's almost impossible to go back and fix any mistakes you've made. But just doing a light mark through it makes it easy to tell that, hey, I've used that one already. But if I make a mistake, I can go back and figure out what numbers I actually had to begin with. So there's my first stem and leaf. Now, this particular chart wouldn't be very useful if I had to do a new stem every time I repeated a number. That's not very organized. All I did was put it in order then. The advantage to this is it uses the same stems for anything that share them. So in this case, that 15 being my next smallest number is going to go there. And it shares the 1 as a stem, but has a different leaf of a 5. So instead of doing a new stem, I'm just going to put a comma and a 5. And I'm going to cross out that 15 that I've used it. What this tells me out of my list, I now have a 10 and I have a 15. This stem gets shared by all those leaves. Whether there's 2 leaves or whether there's 20 leaves there, whatever it's with, it's going to be shared. So that's a 1 and a 0 is a 10. That's a 1 and a 5 is a 15. But again, it's going to be up to that key that we make here in just a minute to make sure other people can read our stem and leaf plot. Now we're looking for the next smallest number in our list. And if we look here, we've got a 20 right over here. So we're going to use it first, or rather use it next. So we got a stem of a 2 and the leaf of a 0. And I'm going to check for any other 2 stems, again, next smallest number. And if I look, my next smallest number, I've got 24. But I actually have more than one 24. So anytime I have a number repeated, I have to represent every number on my stem and leaf plot. I can't just say, oh, there's a 24 there, so that takes care of all the 24s. That really messes with data there, especially when we get into some of the things tomorrow or Friday where we're talking about things like mean, median, mode, range. You've probably heard of these things before, may even remember what they are. When we talk about those, if you've gotten rid of data points, it messes those up. So it's really important to have all of them. So when I've got my 24 here, I can't get rid of it just because there's more than one 24. So I'm going to cross it out, and I have a 4 there for my stem and leaf plot. But to represent these other 24s, this 24 over here, what I'm going to do is I'm going to have another 4. And cross that off because I've used it. And then for that last one, a 4 to represent this 24 down here, and cross it off because I've used it. Now, when I look at my stem and leaf plot, I know I've got 1 and 0 is going to be 10, 1 and 5 is going to be 15, 2 and 0 is going to be 20, 2 and 4 is going to be 24, 2 and 4 is going to be 24, and 2 and 4 is going to be 24. This tells me I have 3 24s there, which is good because I had 3 24s up here. Now I'm going to look to see if my next smallest number, in this case, is a 27, so I'm still not done with my 2 stem yet. I'm going to put another comma and a 7. Cross that off that I've used it. I keep filling up that stem until I've used all the numbers that use that stem. I'll look again, next smallest number is going to be 30. So I'm done with the 2 stem, and now I'm going to have a 3 stem. So a 3, and again a 0. And I'm going to cross that off because I've used it. Look for my next smallest one. Is going to be a 36 over here is next. So 3 and then a comma 6. Cross it off. Again, looking for the next smallest one, which gets me 38 right here. So comma 8. Cross it off that I've used it. And then looking for my next smallest one. Well, my next smallest number is a 62. Now, with stem and leaf plots, I'm not allowed to skip stems, but I'm allowed to not use them. So it's allowed to not use a stem, but I can't skip them. So even though I don't have a 4 stem, I'm going to write a 4, but no leaves. That means there's no stem. That means there's no number there. Even though the stem's there, the 4, because it keeps going, there are no leaves there. That lets me know I don't use that particular stem. Then I go a 5. Again, no leaves. Let me know I don't use that stem. And then a 6. Finally getting to my 62. You notice that I've got a 2 for my first leaf here, not a 0 like I did on the other ones. And that's fine. I don't have to have a 0 as my first leaf each time. It's whatever the smallest number I have in that set. So that's a 62. I've used it. And I'm going to cross it off. Okay, so I'm going to do a quick check here. So I'm just going to count my leaves, because if I count my leaves, it should match the same number of numbers I have up here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I've used them all, I should have 11 numbers up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Always a good idea to check anytime you think you're done, or if you think you're close to done, just to give you a good idea what you have left. Crossing out here helps us also keep from missing ones. So obviously this 95 here is what we haven't used yet. So again, we're not allowed to skip stems. So we're going to keep going. So there was a 6 there. Now we got a 7, an 8, and a 9. And again, we're going to leave that 7 and 8 blank. No leaves over here with those stems. And that lets us know that there are no numbers there. You can't put a 0, because a 0 would tell us that would be a 70. Like we did up here, a 10. We can't leave a leaf off just because it's a 0. 0 is a number too. And it has meaning. But what we can do is just leave it blank, letting us know that there's nothing there. That 90 is going to be a 5 for a leaf. Crossing that off. Again, just checking to make sure we got it right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Lets us know that our stem and leaf plot matches our data set. And that is very, very important anytime we're looking at data. This right here is a stem and leaf plot that we've created. It's much more organized than this random jumble of numbers we had to begin with. And what it does is it allows us to actually take a look at these numbers and get a better idea what's going on. Just looking in general, we can tell we've got a lot more numbers grouped down here in the 10s, 20s, and 30s than we do up here in the 70s, 80s, 90s. We can actually tell a lot about that data, and we're going to learn a little bit about that here in just a moment, what that means and what we call that. But automatically we can start to kind of see where groupings are, patterns, that kind of stuff, and get a better idea of what's going on. Plus, if we had to answer questions about this particular set of data, it's a lot easier to see what's going on now, and going to be a lot faster and easier to answer those questions. Questions that are normally asked about things like this would be, how many participants are there? Well, we've counted our data twice now, so we can tell there's 12 participants if this was a number of participants, or number of scores, or number of books, anything along those. Each one of these entry points, these data points here, in this case the leaves, are going to represent one of those data points, and so we can start answering questions. If these were ages and they wanted to know how many people were in their 20s, it'd be real easy to tell. So 1, 2, 3, 4, 5 people right here on that 2 stem would be in their 20s, as opposed to going through a data set. And this one's not terribly big, it's only 12 numbers, but if you've got a data set of 25 numbers, or if you, again, going into a job that you're actually dealing with sets of numbers and analyzing them, may have hundreds or even thousands of sets of numbers that you're having to represent, and having some sort of organizational system becomes very important. Now, I know some of you are going, wait a minute, Mr. Mitchell, I thought you said it was really important to have one of these keys up here, that up here where my arrow's going around here, where I had red, yellow, and blue, red, blue, and green, these keys, they are very important. I haven't forgotten it yet. I just haven't gotten to it. So down here, you need to write the word key, and we're going to pick a data point. It does not matter at all. Often it's the first one, but it doesn't have to be. And every once in a while, you'll have a stem and leaf plot that the data point they pick isn't actually on the graph. That's pretty rare. Most of the time they do actually pick a data point just because it makes the most sense. I'm going to use the first one, which is 1, 0. They use a 1, and then they use a long line and a 0 to represent the bar between the stems and the leaves. So this is just kind of a symbol representing this long bar in our T-chart here between the 1 and the 0, just to show which one's the stem and which one's the leaf. And this 1, 0 in this case represents our 10 from our original data set up here. So I'm going to have 1, 0 equals 10 as part of my key. All right. So since we've got all that made, let's look at some things that we can do with this. Okay, so one of the things you can do with a stem and leaf plot is actually determine what's known as a skew. A skew is when data is unbalanced. It's when the mean is pulled above or below the median. Anytime this happens, the data is said to be skewed. What that means is that it wasn't distributed evenly. This can tell you any number of things about data, but mainly right now what we're focusing on is being able to recognize that there is in fact a skew and what type of skew there is. With the stem and leaf plot, the way you determine that there is a skew is that you actually turn your stem and leaf plot 90 degrees. Just like that. And you're going to take your pencil and kind of roughly trace along the outside of your data. Now when you do this, you give a general outline of what's going on. Now, one of the ways as a math teacher that we try to help people remember skews is we get a little bit of art going on here, and we turn this weird little lumpy picture here into a whale. Let's try that again. And there's a whale. You got your little spout there. That's unimportant, but you know, it's fun. So what happens with this whale? The mean follows the tail. And the little saying we use again is the mean whale hits you with its tail. And that's just to help you remember that the mean follows the tail. Why is this important? Because the skew follows the mean. So in this case, the mean was pulled to the right. So this is skewed right. And you're going, but wait a minute, Mr. Mitchell, all the data's on the left. Right. Correct. Since it's on the left, all these data points over here on the right being pulled over, actually pulling that out of balance, means we're skewing. Skewing meaning out of balance or pulled off center. In this case, being pulled off center with the median, this stuff over here being pulled over to the right is where the skew is happening. It's being pulled off balance. If everything was all over here together with that big group, it would be a symmetrical set of data. Knowing that the mean whale hits you with its tail, later when we talk about distribution and we talk about any number of other things, that's going to come up later. It's important to know whether it's a left skew, a right skew, or whether it's symmetrical distribution. And since I've brought those up, let's do just a little bit of vocabulary. So with a little bit of vocabulary, we've got skew, we've already talked about, the mean being pulled above or below the median. Skewed right means the mean is greater than the median, the whale's tail's on the right. Skewed left means the mean is less than the median, the whale's tail's on the left. And symmetrical means the mean is equal to the median, and essentially the whale's looking at you. The tail's going to be there in the middle. Knowing that the mean is greater than the median and the mean is less than the median or equal to is going to be important. You are not going to be doing that today. Right now, what you're going to be working on is recognizing the shapes of the data with the stem and leaf plot. So back where you did on the last slide there, where we drew a line on the outside and figured out where it was skewed, is the main thing we're focusing with that today. Mostly what we're focusing on is creating those stem and leaf plots and being able to answer questions on them. That skew does come in and is important, but we're going to develop that. So if you don't understand all that right now, have that vocabulary in there. Start to work on learning those words. I'm actually going to say that should be part of your homework, is learning these vocabulary words right here and what they mean in association with these pictures here, because we are going to be developing that understanding, and having the vocabulary down is going to make that easier for you. All right, so what we have here is a little larger data set this time. Again, going to start with a stem and leaf plot. So the first thing we're going to do is kind of organize this as we go. And the first thing we need to do is find our smallest number, because regardless of anything else, we got to find the smallest number. Now, the challenge with this is we've got some decimals here, and some of you struggle a little bit with understanding how decimals relate to each other. Anything to the right of the decimal, the further away from the decimal it is, the smaller it is. The smaller this number is, the further away from zero it is. Lots of things that go along with that. Know that the numbers out front are definitely going to make a difference, so because those are our whole numbers, so definitely zeros are going to be smaller than ones, and ones are smaller than threes. When you get these actually comparing, so this one I got 0.37, so think of that as like a 37 there. I get to this one over here, it's like a 61, so obviously 37 is going to be smaller than 61. 37 is going to be smaller than 60, which is this one here. Going along, 35. Okay, so 35 is smaller than 37, so we've got this one, 35 smaller than 61, 35 smaller than 95, 86, 95, so 0.35 is my smallest number. The challenge with this is we've got a decimal there we've got to represent. Now, this one, the leaf is going to be easy. It's going to be a 5 because it's always the digit to the right. It's that last digit in the line there, regardless of place value or anything like that. The challenge is that your stem over here has to match. So if this smallest place value here, this case is the hundredths, so 2 digits, you've got to have over here matching up on all of those. That last one's always got to be the hundredths place, or it doesn't work anymore. So what's actually going to be over here is actually going to be a 3. Now you're saying, well, there's a 0, 3 there. Right, but again, as in most cases, 0 before a number doesn't change its value. Zeros after numbers do, but zeros before numbers don't change its value. And in this case, if I had the 0 before it, 0, 3 is the same thing as 3 there, so we're not going to put that there. And we're going to cross this off to the side. Well, right here, since I've just created that, I'm going to go ahead and make this key over here while I'm at it and say that 3 long bar 5 is equal to, not 35, 0.35. Since I've already got that in there. Now, while I'm looking at my other numbers, I'm looking, do I have any other 0.3s? And I've got one right here, 0.37. So 0.